All right, everybody. I did a longer version of this kind of a problem in the first practice exam, so I'm just going to kind of go through and solve with a little bit less explanation just to get to the answers, just in the interest of time, because I want to put another practice exam for you that you'll be able to kind of solve and work with. I won't do videos for that third practice exam, but I will make it available later today or tomorrow. So, an object is launched horizontally from a height of 125 meters above the ground with a speed of 30 meters per second, and we want to know a number of things about it. First, let's just draw a picture. To be clear, the vertical displacement is 125. It's launched horizontally at 30 meters a second. And so we're going to have 30, this is 0, this is unknown, this is unknown. Our S is 125, our vertical speed is 0. Our V is unknown, our acceleration is 10, and our time is also unknown. So we can go ahead and get the time it takes to hit the ground. So we're going to say that S equals 1/2 AT squared plus UT, and that's going to be 125 equals 1/2 times 10 times T squared, and that's 250 divided by 10 is T squared. We're going to square root that to get the T, so we're going to get a time of 5 seconds. All right. Now let's get the horizontal distance it travels. Now in this case, it's traveling like this and it just kind of lands on the ground. So let's be clear that the time it takes to fall is the time it takes to go horizontally, which is why there's no need to necessarily double anything. So here, this is also going to be 5 seconds. So we're going to basically say that x is v0 times t plus x0. So we're going to say that x is 30 times the 5 seconds plus 0, and that's going to give us 150 meters right there. All right. Now, for part C, let's be clear. Let's get the speed in the vertical direction when it hits the ground. So that's going to be v equals at plus u. And that's going to be 10 times 5 plus 0. And that's going to be 50 meters. Now, one thing I want to note. When the object hits the ground, this is the speed it's going at. And let's be clear. In the horizontal direction, that's 30 meters per second, which we get from the problem above. And it's also going downwards with a speed of, and I'm sorry, this is meters per second here, 50 meters per second that way. So that's what we just solved for. So the total speed, think of these as the legs of a triangle. They're actually vector components. So what we're going to do is we're going to take this part, and I'll call this part Vx, and I'll call this part Vy. I'll call it x because it goes in the x direction, and y because it goes in the y direction. Pretty logical. So my total speed is going to be Vx squared plus Vy squared under a square root, and that's going to give us 900 plus 2500 under a square root. And when we get that actual speed, we'll go ahead and do that now. 900 plus 2500 under a square root is going to give us a final speed of 58.3 meters per second. That's how fast it's actually going. All right, so that is part C, B and A of problem 7. Thus, we've completely solved it.